Hello. Hey, Crazy Wolf. Just catching up on the news too. Got to see what crazy shit's going on now. Lots of crazy shit. Okay. Enough depressing news. Okay, so yesterday, as a non-millionaire, in my days as a programmer, non-millionaire, I ran into an issue where I was redefining malloc and free on the command line for the compiler, which works great in GCC, and Clang not so much for MSVC. After doing lots of digging and having flashbacks to many years gone by, I remembered some context and found some documentation that confirmed my suspicion. Yes. So MSVC, you cannot statically link anything to replace the memory allocation functions. You can replace them in situ. So, like if you had an executable target and you asked MSVC link to make that, and you overrode malloc and free and a whole bunch of other options they have, that would work. But you can't create a static library and then that replaces malloc and free and then try to link that. Won't work. You can do it with DLLs. After reading that and working through a quick example, Hello World, to prove that that was in fact the case, I sort of backed up and said, okay, like, so, dyn call alloc is a header that checks if DC alloc mem, if the symbol DC alloc mem or DC free mem is undefined, then they define them to malloc and free. Now, this is actually a bug. So I uncovered a couple bugs in dyn alloc, which I'm going to send them a patch and see if they decide to use it or not. Their call. What's curious is it's obvious that they never tested redefining these, or if they did it a long time ago and stopped testing it. Because what's interesting is they include standard lib here, but it turns out that there's another module that requires standard lib that doesn't include it. So they were relying on the fact that this header was always, that these symbols were always undefined, and that they would define them so that this include would happen. So that's one small issue. So I actually fixed that, sort of. I fixed it on my end so their code would compile correctly. I'll send a patch to them that actually fixes it in their code. I mean, ultimately, you just either, well, actually, this include should be taken out and just move to the module that needs it, you know, and then the other modules compile just fine if these symbols are not, if these symbols are already defined. So, so that was one issue. And then I came across this yesterday during the stream, but yeah, I don't know, my brain wasn't working. So all these compilers let you pass a command line parameter telling it to explicitly include files. You know, so it's almost like every single file on the command line that's to be compiled, you're telling the compiler there's an additional include statement at the very beginning, and then it executes that as if it were written in the source code. So, and so this was the solution. So what I did was I created a dyn alloc header on my side that just prototypes the replacement functions that I'm using. And then defines the symbols that they're expecting. And since these are then prototyped, the compiler is happy and everything works the way it's supposed to work. So, so for MSVC, that's the //FI, which is force include, and then a path. And there's two libraries here, so I have to do it for both of the libraries. For GCC and Clang, it's -- include equal and then the path. So And since there's two compilers that work that way, I use generator expressions. Now, one other little interesting thing here is that in the Microsoft tool chain, the assembler and the C compiler are two separate tools. In the GCC Clang world, they're one. So I had to use these generator expressions to filter out assembly files, because when they do invoke the assembler through the C front end or C++ front end, it doesn't like these options. So these ended up being a tiny bit more complicated. So the net benefit to this solution is now I'm not globally overriding malloc and free in these libraries. I'm just overriding their symbols that they provide. There was one other, what I think is a bug in their code. Of course, I can't remember the file name. And let's see. Yeah, it's this guy. So these two lines here were just calling free, not calling DC free mem. And the struct that's being freed up here is in fact allocated with DC alloc mem. And yes, the default is malloc and free, but if someone were to redefine these, then this would not be right. So I went ahead and just changed this so it was consistent. I searched through all their other code. I didn't see anything else that was broken like that. So yeah, so this fixes the problem, and now everything's happy. And it only took me like a day to figure that out. So that's good. And like I said, I'm going to send the Dyn call guys a patch. They have their own private Mercurial repository, so I'll just have to send them something, an email, the old-fashioned way. I don't, the struct stuff in Dyn call, I don't really know how baked that is. I did write some test code a couple of years ago that used it. It seemed to be okay, but I don't know. It's very possible that code's kind of in their library. That code's kind of not well maintained. None of their examples really go into details about it, so it could be aspirational code. Like they would like it to work, but it's not 100%. I don't know. So, Zetawap asks, what architect... I can't speak today. What architecture... Oh my God. What architectures... Am I getting reverb? I swear I'm hearing myself twice. No? Okay, it's just my brain. What architecture can you do assembly for? Yay! I can read. x86, x64, ARM, 68,000, Z80, 6809, 6502, 65816, several variations of TI, AVR, SMC, lots of TI, TI DSPs, TI CPUs, TI GPUs, mainframe, microchip. So PIC, tons of different PIC controllers throughout the years. Power PC, although nobody uses that anymore. RISC, like RISC 5. I'm probably missing some. Many years ago, there were some other Intel microcontrollers that I used. I'm trying to remember their number. They were in a 4000 series. I don't remember the exact number. A lot. Many. And see, this is the thing, right? Like, it is true that assembly language is not portable directly, but there's a handful of common architectures in use out there, right? You've got the Harvard architecture, which is pretty common in like microcontrollers. And once you understand, and I guess this is, see, a lot of guys, I say guys, a lot of people in the 70s, 80s, as kind of the home computer thing was becoming a thing, we got our start with electronics, not with programming. And so I think I'm just going to make a general statement. I don't know if it's true, but a lot of guys that either migrated completely from electronics to software or ended up being a hybrid. I ended up being a hybrid. I think it was somewhat easier for us to, like, assembly language or machine language, programming in a monitor or with dip switches just didn't seem like that big of a deal, right? And if you understand like basic digital electronics, how an address decoder works, how, typically memory, be it ROM or RAM, is mapped to address lines, on a bus to a CPU or to multiple CPUs or MCUs or specialized devices. So then the concepts of memory mapping and all of that, once you understand those, a lot of those ideas are portable. Like the ideas, the concepts are portable. So for every ISA you come across, once you've done a couple, the amount of extra effort to pick up a new one is extremely small. And as you do even more and more and more, it just, the commonalities, your brain understands the patterns and what to expect. Now, there's always care to be taken on every particular ISA that you pay attention to the details, right? Because just because like two ISAs have the same instruction or seemingly the same instruction doesn't mean that they are exactly identical. So you have to be very careful to not over assume, right, too much. But yeah, that core conceptual understanding, it can go a long way to helping move from one ISA to another. Yeah, so like Cyanox mentions like instruction parallelism, all that stuff. So like a lot of DSPs are sort of unique beasts, right? And obviously, if you are dealing with like some kind of proprietary FPGA, and you're programming that at some level above Verilog or gate logic, you have to really know what's going on there. But that's like if you're one of the people that's doing that, that's you know what you're doing, or you know how to figure it out. Yeah, so if you're learning electrical engineering, by the time you're done, you'll have a good handle on the concepts. And I think to some extent, it depends on the exact curriculum. I think some institutions focus on more deep dives, some focus more on the conceptual level and not as much practical, lab work. But this is called Sea Lion. It's one of the many JetBrains sort of dev stack configured IDEs. Technically, the IntelliJ IDE is a platform, and it's all just plugins. And at one point, they were kind of going in that direction, but then they sort of started specializing. So Sea Lion is the IntelliJ platform with plugins that are meant for like C and C++ development. It is paid, but I like it. I think it's worth it. They had a period of time where it wasn't super stable, but they've gotten past those issues, and it's pretty solid now. Okay, so here's what I want to do, I think. So before I fixed that allocator issue yesterday, I had pulled in the Iron FE micro scheme interpreter because I want to use it for config files. And I wrote just a quick test to just verify that I could actually use the library, that it was working, it was building correctly, and that seems to be the case. But this is not, I like low level, but this is too low level. This just proves that the library works. Yes, the title is a jab at Tech Lead. So I should have put X never Facebook, X never Google, X never Microsoft, X never, but yeah, that would have been crazy. So we're going to wrap this up. I'm still fighting with my key man. Oh, I never changed it. I guess I'm using Windows now. Duh. That key never did anything before. I know. I'm sorry, Cyanox. I shouldn't do that. I shouldn't be selling the hopium, you know. I'm turning into a scammer. It's not good. Come on. Yep. Okay. Okay, so the way I'm thinking about this is I don't intend to expose this micro scheme generically. I just want to use it for config files. So, much like other modules that I have, if we take a look at like an example of how this stuff gets set up, in the main of my test program, yeah, it's a micro scheme Lisp-like language. I say micro because it's very tiny. It doesn't do much, but it does enough for like config files. So for every module, and for those of you who are like thinking OO terms, when I say module here, you can think of that kind of like an object, but it's not. It's a C++ module that has a public API and has some private bits that you can't see. And there's an interface that lets you set that module up and then use it. So the memory system, the logging system, all these different subsystems, right? That would be another way of thinking of it. These are all like subsystems. The networking, file system, FFI, all that stuff. So this config would be in the same vein, right? So typically the way I do this is I like namespaces. Trying to think of an example. Yeah, let's look at the log module, right? So all the types, this we can ignore. This is a forward declaration, but all the types live in the base code top level namespace, so they're accessible. Now, when I say accessible, I mean you don't have to know a 10 level deep namespace to get to types. They're just under base code. Now, the downside to that is all your type names are in that one namespace in general. So, you have to think a little bit about how to name things. And, if I really do have two things that use the same type name, I'll just put one of them in a namespace, but I try not to do that if I can avoid it. And then whatever the module is, I have a namespace then under that where the API lives. And see you later, Cyanox. Hopefully the beating isn't too bad. So then I have a namespace for the module, right? So log. And then I'll typically have a sub namespace there, system, that is sort of, typically that's where the time management of that module works. So So I could call this subsystem, or I just use system though because it's shorter. But that's really what it is. So, the Finny here is the shutdown for the whole log subsystem, as where the Finny at the log level is just for a logger. So hopefully that makes sense. So that's kind of the design pattern, if you will, that I'm following. So obviously here we're going to have a config namespace, and since this is going to be like a subsystem that will have a life cycle, and then these are the user level, let's say API goes here. So again, typical pattern here is that I have a finalizer, which I call Finny, kind of ironically, for the module or the subsystem. And the one type that I do consistently namespace, sub namespace, because it's the same in every module, is I have a enum class that's a byte in size called status T. And as we'll see as I get through this, these are the integer keys that are going to be used to look up localized strings or errors or things like that. And OK has to always be 0. Now, right now, the values are implicit in the enums. We're going to go through and make them all explicit. But OK is always the same. It's always 0. And in the types header, I have a macro. I think it's in here. Yeah, I have a macro called OK that just takes whatever type is passed in, or whatever is passed in here, casts it to an integer and compares it to 0. And so all of the APIs that could fail for some particular reason, they typically return this status T. And then calling code can use macros to inspect whether or not something bad happened. So then we need to initialize and I do not use new and delete. I don't use malloc and free. I have my own memory subsystem that uses custom allocators, and then underneath those is DL malloc, but you could swap out DL malloc for TC malloc or JE malloc or whatever. I personally like Doug Lee's allocator, but so because of that, in my code, I have to pass an allocator in. That's one thing C-Line doesn't do, right? So I have to pass allocators around. Typically, those get passed in, and well, I say typically, depending on the nature of the thing. In this case, we're dealing with a subsystem, so we can pass in one allocator for that subsystem, and that's a reasonable assumption that, okay, I'm going to give this subsystem this arena or this slab allocator or whatever, and that's what it uses. Okay, so oops. So in the module, so everything I was just doing was in the header. So in the module, we know everything's going to be at least in the config namespace. And then some of this is going to be in the system namespace. And the format key isn't working. Control. Control Alt F. No, why isn't that working? Yes, I do appreciate anime. Okay, so on the right hand side, we have the header. On the left, we have the CPP file. So inside of the CPP file, I'm going to define a struct that represents our system. And because this is inside of the module and I'm not exposing it through the header, it's private. And we know for sure we need to put the allocator on there. And then typically what I do for these is I have a global variable. And I prefix my globals with G underscore. So why global and not a static? Well, so static, statics are generally okay, but my rule of thumb is if it's a primitive type, so if it's an integer, if it's a pointer, if it can be trivially constructed, static is probably okay. In C, static is like almost universally okay. In C++, it gets a little bit convoluted because of constructors and destructors. So again, my general rule of thumb is if it is a trivially constructed type, then static is probably okay. If it's not, then I typically use a global because then that just tends to be a bit more deterministic in its behavior. But note that this global variable is not exposed, right? I'm not making it extern in the header. Nobody else can see it. So it's global, but it's local to the module. So then when we initialize the subsystem, we already have that global. So we just need to start setting it up. So far, that's pretty simple. Now, we know, based on the tests that I built, that we need to set up this scheme interpreter. So now the question is, so the scheme interpreter, the way it works is a fixed heap. What does that mean? It means that you, as the user of the library, allocate a block of memory somewhere. You pass a pointer and you tell the scheme interpreter this is how big it is. And then the scheme interpreter sets the heap up for itself. But that's it, right? It doesn't grow the heap. It doesn't, if it overflows and the garbage collector can't free up memory, then done. For the purposes I'm using this, in these, oh God, I can't speak today. For the purposes in which I am using this interpreter, that's okay. In fact, that's really what we want, because we don't want this thing just growing memory usage. It'd be better for it to hard fail, and then I know that I'm either doing something stupid with it, or I need to give it a tiny bit more memory or whatever. Now, with that said, then the question is, well, I could make it configurable, right? So in our init, we could pass in what we want our heap size to be. And I'm just going to go with 64K as a starting point. I don't know if that's enough. That's probably enough, but we'll see what that ends up looking like. So, there it goes. Now it's working. Okay, so the next step then is we need a FE context. And I don't want to forget the lessons from yesterday. The FE header does not what am I trying to say? The FE header does not do it doesn't check if it's a C++ compiler and wrap everything in extern C. So, and I didn't want to change. I try not to change external libraries if I can avoid it. If they need to be fixed, I'll fix them. But I try to avoid it. And in this case, it's easy enough for me to just wrap the header, and that solves the problem. But there is an issue here, and that is that I, in the CMake file on the interface library, I believe, yes, I added this path to the include path for that target, so that any other target that refers to my library will get that. It will inherit that include path, but only for that target. But this target itself doesn't know about it, so I have to fix that. And yeah, and that would be here. But I don't. I don't want this to be public. So, okay. So that should solve the include issue. And as a non-millionaire, this is the joy of my life. I mean, watching CMake is mesmerizing. It's awesome. Yep. So there we go. Now the header path is fixed. Okay, so we have a pointer to a context. So if we go back to the test that I set up, the setup here is pretty simple. So we already have the heap size. No. So I'm going to temporarily copy what I had in my defer statement to the Finney. I'll have to touch that up. We don't need to assign this to a local. And then this shouldn't be whatever allocators passed in. I'm just a spaz today. And then FE open is the API in the scheme interpreter to initialize the context. So now that we've allocated a blob of memory, we can just pass that in. We don't need the GC thing here. And then here, we need to close the context. So what this does just goes through and recursively garbage collects. And the primary reason for that is because the scheme interpreter doesn't know if you've registered non-scheme objects external to the interpreter and the interpreter's heap. So if you do have like C functions or C objects, it will try to finalize those, which we'll take advantage of here eventually. And then we need to free the memory that we allocated for our scheme context. So let me make sure that compiles. Should. Mikey MSVC likes it. So, all right. Yeah, Lori Master says global, those are illegal. Yeah. What's my favorite anime? I really liked Samurai Champloo. I don't know why, but I don't know. I just thought it was really entertaining. I'm trying to think. You know, if you take all the filler out of like Naruto and Bleach. Those are like whatever would be left after you take the filler out would be good. I liked Witch Hunter Robin for the most part. Yeah, I mean, those are what's coming to mind. I'm sure if I really thought about it, I'd come up with something more definitive, but what percent of a non-millionaire are you? 0%. I am a failure. Okay. So now the thing to do is first think about what order I want to load this in, because what is the default longer? I think this is mine. Yeah. I think this is what I want to do. So our config system is going to depend. It depends on the memory subsystem, so that has to happen first. And the memory subsystem, like, it might be configurable at layers beyond like the initial default layer, but yeah, it's too much of a hassle to try to make that configurable. So I think that's okay. And then the default logger is also likewise, I think, okay. This is like the ultimate fallback that just writes to standard error, which wherever that's redirected, that's what you get. So then that means our config module can safely use the memory subsystem and the logging subsystem, and it'll be fine. And then what that allows us to do then is, like right now here, I have additional loggers that are logging to files hard-coded here in the setup. And this could be moved to configuration behavior. So this, I think, makes sense, at least right now. And then yeah. So then the config system needs to shut down before the log and the memory system are shut down. So that looks like the right order to me. And then by doing that, this can go away. And then in our user level API, hey, Stunt. Yeah, I was swallowed by the evil beast. Yeah, so what I'm doing now, and this is sort of, I'm going to go in steps here. What we want to do is sort of mimic the basics of just evaluating gosh no. Okay, yeah, so this is another thing that happens. So concepts. So this is a C++ concept. And concepts or constraints is really ultimately, and I think they chose the word concept because constraints longer. But that's really what it is. You're saying, hey, for a given type T, there's a concept called string concept, and it can be any, as long as it, meets one of these constraints, then it's valid. So, and the nice thing about constraints is that instead of it being spine, which is mysterious and non-obvious, the syntax here reads like C++. So we have a bunch of logical OR constructs. So it can be a slice concept, it can be a static string concept, it can be a dynamic string concept, right? So that's real easy to understand. And then all of these others are just examples of what those constraints look like. So as an example, a static string concept would be any type that has a type def in it that is called value type, and also has a type def in it that is a standard, I think it's standard Boolean shit. I can't remember what they're called. Oh, integral constant. Yeah. So if it has an integral constant and it's true, then so if the type has a type def in it that's called isStatic, and that happens to be a standard integral template type that is true, then there's a requires here, which looks like a function, but isn't. It's really just a bunch of constraints. So then we're saying, okay, then that type has to have a type def in it called value type. And then it has to have fields that match the constraint on the right side of the arrow operator. So if it has a field called T, so if T, which is the parameter passed in here, if it has a field called data, and that the type of data is the same as our value type def, a pointer of that, then it's good. And size is a U32 and capacity is a U32, then this constraint is met and it's a static. And I'm actually looking at array, sorry, but you'll see that all these are very similar. But so that's the general idea, right? And it's dynamic if it has an allocator and it's not flagged as static. But this is still C++, and life can't be easy. So even though using a constraint variable, a constraint parameter like this, which is very convenient, right? Because you don't have to do the template nonsense here. The compiler does all that transformation for you. And any string concept then can be passed in here, right? So what does that mean in practicality? I could pass a strt, I could pass a slice, I could pass whatever matches those constraints, whatever type it is, can come in and be the source parameter. But it's a template, so it has to be in the header. It can't be in an implementation file. I haven't double checked if there's some magic with modules. I doubt it. But there could be. I just haven't looked at that enough. So in this case, the guts of this thing are in the CPP file. The header doesn't really know any of the nitty-gritty details of how this thing works, which is the way I want it. But what that means is then, even though I have to have the concept interface in the header, I can't really do anything in the header. So what that's going to mean is we have to do something like this. So in the module, we're going to, so string concept, we know has a data field on it. And actually, you know what I'm going to do? Because I'll cast it inside the CPP file. And we know it has a length, and we can just pass the return object straight through. So then what that does is that allows us to accept a very flexible concept parameter, and then we can shunt the details into the module and do the do, as they say, but not to do on YouTube. He's cool. Are concepts like Rust traits? No. Traits are sort of I'm trying to figure out how to say this without pissing Rust people off. Traits are like interfaces in Java or C Sharp. I hesitate to say Go because Go has some weird shit, around how their interfaces work. But there's probably enough similarities there. So in that sense, traits are a type in the type system that aren't ephemeral, right? Like, I don't know all the details of the Rust compiler, but what type erasure happens, that's happening at a very late stage, as where in C++, concepts are just a representation of existing template functionality in C++. Like, there is something new there in the sense that you can do the requires clause and use more expressive code, but fundamentally it's still all it's doing. All concepts are giving programmers a way to express constraints they could already express with Spine without causing them to have a seizure trying to figure out how Spine would work, right? And for those of you who don't know what I mean when I say Spine, wrong one. I don't know, there might be something, Oh, I'm gonna have to do it the hard way. I'm gonna try to find something really egregious. Well, actually, so here's an example, right? Where prior to I keep saying constraints, prior to concepts, you had to do things like this with Spine, right? You had to create all these synthetic types, right? So this is what you get, right? You get a decal type through using, you get these sort of just empty structs, sentinel structs, right? Because it has to be a type. The template system has to be anchored to a type in C++. So, but without concepts, the only way you could do this stuff was to build this horrific artifice of all these sort of synthetic types, right? You got to remember, templates are, even though non-obvious, a form of compile time code generation. So what's happening here is, by constructing all these artificial types through templating, you get particular variations of those types that match certain configurations. And trying to find something that's like really crazy egregious. So far I'm not seeing it, but here's an example, right? I mean, this is pretty simple, But this is what spine A looks like, right? So enable is artifice, right? It's a flag. It's not. This is how you create a variable in a template for the purposes of code compilation, right? So, and what this means is that a truncating iterator at some point, somewhere else in this code base, they'll be able to pull out enable as a type def and look at it and say, oh, is it set, right? And then from that, do some kind of conditional compilation. So all this stuff where you see in code, C++ code, where you have all these extra. Here you go. Needs conversion, right? This is a flag that's being set. It's it's a flag. It's a type that is used as a flag. So anyway, this is what concepts largely mean in C++. They are a representation of template constraints in such a way that they are not mind-bending. Now, unfortunately, they're not complete. So there are scenarios where you still have to sort of fall back to Spine. And of course, the more ambitious you are with how you want to use them, the more likely you are to run into those limitations. But I hesitate to say, I hesitate to use the word compile time construct when comparing it to Rust. They're both compile time constructs, but they kind of have a different level of traits are they're closer to classes, but not exactly the same. Is how I would. Concepts are there's no implementation at all in a concept. It's literally just a way of saying to the compiler, hey, if this thing looks like this, then it's okay, right? But like you can't cast to a concept. It's not a thing like that. So I don't know. Hopefully that made sense. Hey, Gmon, Laurie Master. By the way, C++ 20 modules really disappoint me. Yeah, me too. I thought they were going to make programming C++ less reliant. Yeah, exactly. No. Still got to compile. Yep, exactly. No, you're not missing anything. Modules are not. I talked about this yesterday. Modules are. Look, again, you can slice these things in so many different ways. One way you can slice it is say, what else could they do? They had to make some incremental movement. And anything they did, either you end up with a solution that is so dramatically impactful to everything that's out there, it can no longer be backward compatible. And I think the way most people read modules in C++ is, oh, it's going to be like Rust, or oh, it's going to be like, any other modern programming language. Sorry, allergies. I'll probably have a sneezing fit here any minute. But they're not. Really, modules, as they are in C++20, are an incremental step toward moving in the direction of potentially having, in like 20 years, let's be realistic, of C++ being closer to other modern conceptions of modules. And as I mentioned yesterday, I've been following progress like in CMake and Premake and a couple other tools in the build space around modules, and it's non-trivial. So yeah, it's and the problem is, which is kind of the case with a lot of things in C++, it's kind of you have to ask, okay, well, if I change my code base to be modules, how easy is it going to be to reuse that code if I want to make it open source, unless they're modularized in their build system and in their tooling and everything? This shit's not going to work right. So then I'm not going to get any uptake in my library. So I'm not saying we won't see some, things pop up in the next couple of years that use modules here and there. But yeah, I think it's going to be very, very slow burn. And it could very well be that modules got delivered in C++20 in name only. So it's kind of a milestone. They did it, but it won't see much uptake until 2 or 3 revisions down the road. I could be totally wrong. I don't think so, but what I hear from most people is the same thing. It's why, and you have to do extra stuff. And there's a weird naming convention for files. It's like, why do I have to do all this extra stuff? So anyway, yeah. Okay. So I'm just going to take the code that from the test that is okay. Okay. This is a font called Pro Font. And you too can use this amazing font and many, many others by cloning this repository and running the appropriate install script. And they even have Powerline symbols in there for you. So it's awesome. It is the coolness. What do I get now? I check if it's no. Oh, is it in the... No. I'm trying to figure out how to get a... Okay, so he's just, it's a bool. All right, fine. That works. Okay. Okay. Right, so we stash the index to the current garbage collection stack. We open our string with the length that we provide in memory. If that fails, then oh boy. We defer a close on that file handle. We call into the scheme reader with that file handle. We get back an expression from the reader. If that's null, then our return object here, which we're going to assume is valid, we assign that to false, which is the same as nil, which is true in Scheme. That's typically the case. So, and then we say, yeah, okay, everything's fine. It was empty. And otherwise, we evaluate whatever was read, which gives us another scheme object. That is the actual result object. So we assign it, we restore the garbage collection stack pointer, which would potentially cause the garbage collection to occur, and we return okay. So now in our tests, what we can do is include our configurator, and say config eval source and the address of obj and so I'm gonna have to, because I don't really want to wrap all of that. I mean, there's arguments to be made that you could do that, but yeah, I'm gonna be lazy. So we need to add something to our system interface here that lets us get the context, because again, this is, oh, for crying out loud. This is private to our module, so we do have to have some kind of getter for that. That anymore. Yeah, so look at that. So much smaller. And our source string is one of my slices. And so that you can see where the concept works here. You know, this is a slice. That's a valid string concept. Away we go. Right, so all the initialization code moved to the main in the unit test program. We wrapped up being able to evaluate one scheme expression in a string. We're going to have to do some other wrapping here, but as a start for the replacement of what we had, that's pretty good. And the survey says, kaboom. That's funny. Oh, yeah. So that's actually in the initialization code of the test runner. Right. So, oops, I was off by a couple lines. Yeah, we got to have a context. Sorry, my bad. Oh. Yay, look at that. It's amazing. Okay, so hey, Romania, hey, it is going. To an external observer, I appear to be moving very slowly because, in fact, I am near the speed of light. Okay, so let's do this. It works on Windows, spelled D-O-Z-E. Hey, Bryce. So let's go to Linux land. Give it a quick test. I'm also going to run Valgrind on it, which is much easier to do in Linux than it is in Windows. I hate how Ubuntu locks that shit. Ugh. Was that Arabic? B Flynn? No, BF Land. BF Land. Oh, is that Meshuggah Sahin? I forget. I got him out to share. Okay. No, it's okay. Out of curiosity, what language is that? Turkish. Okay. As I was pronouncing it in my head, I thought, oh, that kind of sounds like Arabic in my head. But okay. Make sure the tests run. Oh, and they run so much faster. It's insane how much faster they run. I really wish I understood where the bottleneck is on Windows. Like on Linux, that little test program for the scheme interpreter runs at 14 microseconds. I mean, I think it takes like 500 or 600 microseconds in Windows. That's just insane. Yeah, 800 microseconds. Now, I don't know. If I run it again, I mean, it could just be a difference in caches and stuff, I guess. I don't know. Not really. I mean, yeah, okay. So, like, running it right after a build, it's probably evicting stuff. So then it's like twice as slow. But then after running it successively, but it's still 578 microseconds. That's just nuts. If I run it without the debugger, it shaves 100 microseconds off of it. Holy shit. If I run it without the debugger on Linux, it shaved a couple microseconds off. But it was already pretty damn fast. It's a quandary. I mean, I'm not worried about that. I'm really curious. Okay. Always good to make sure we aren't leaking. Perfect. All right. My theory stunt is that it is the I/O system in Windows. It's either NTFS itself. I mean, I have a suspicion it's NTFS. But it could be more nuanced than just that, right? The Windows security model is very different from the rest of the world. So there could be cost in Windows making sure you have rights to things. I don't know. It's strange. Here, let me run it just from the command line. I mean, and I'm using CPU timing to do my profiling. And so it's the same CPU. So, and I do it that way on purpose so I get the same relative timing values. So I'm not relying on like any operating system level clock. Where is it? Okay. What did I call it? Oh. There it is. Yeah, no. That's what it shows up as. You know, okay, I'm curious. The only thing I can think of that could be a problem that accounts for the difference is in the timer calibration. I wonder. The thing is, though, it does feel like subjectively it feels slower in Windows. Is the same. I think the same profiler code is running in Linux. Yeah, it's the same code. Let's do this. I always forget the stupid printf. LF, of course. Oh, this just essentially, we just want to make sure that we're forcing the CPU into a state where it's interesting. On x86-64, I'm not even really sure how to explain what this fence would do. It would be easier to explain it on ARM, but yeah, actually, let me look at the what is this one? My memory when I was writing this is because I'm using like get CPU ID and I'm using the counter instructions to the timer instruction on the CPU to get the most accurate count. You want the CPU to go into a non-sequential memory access state, but it's been a while. Right. Okay. Yeah. So what this does essentially is, regardless of how many threads you have running, this sort of puts the CPU in a read-write state that guarantees ordering globally. Now, this is an STL abstraction on it. So, like, what exactly it's doing, right? So the ACQ rel does not flush the store buffer. Yeah, so normal x86 loads and stores have essentially ACQ and rel semantics, but x86 atomic read, modify, write operations always get promoted to a sequential CST because the x86 SM lock prefix is a full memory barrier. I was really hoping I'd see some millionaires streaming today. For those who aren't aware, the title of today's stream is sort of a parody of Tech Week. Okay. So I'm just curious to see, like, what that calibration multiplier is. So on Windows, here, let me run it a couple times because so it's coming out to pretty much the same 0.277795, and then on Linux, .277423. 423. Yeah. That could be. It could account for some of it. But they're not that far apart. And that's what? Tenths, hundreds, thousands. That's a very small fraction. So, yeah. I would say that code's behaving more or less the same. And I mean, I would be really surprised if there was no variance at all. Yeah, so I don't know. It's definitely one of those mysteries that doesn't keep me up at night, but it is curious. Windows definitely seems to be much more variable in terms of, like, sometimes, like, right there you go. One time out of what, like, I don't know, half a dozen times I've run this thing, Windows manages to run all 45 tests in 147 milliseconds. And now it's pretty close, right? So now Windows is 154, Linux 128. So Linux is still a little bit better, but they're much closer. So it's like, I don't know. There's some odd caching something going on there. Do I know any millionaire programmers? I know some, yeah. But I'm not one. Okay. Right. So the next thing we want to do, I'm not sure what this exact song is. Yeah, this is from what is it? Sen no Kiseki, which, yes, is a RPG. What does it take to be a millionaire programmer? People get really mad at me when I say what I'm about to say. Luck. Now, when I say that, people assume, that it's all luck. And now that's not the case, right? But it is a hefty portion of the equation. So one of my brothers went to Columbia Arts in Chicago and studied music performance. And one thing that I used to, because I was working downtown Chicago a lot at that time, this was in the late 90s, early 2000s. Since I was going downtown a lot, either he and I would ride the train down together, or I'd drive down there and he'd ride with me. I'd take him to school, and I got to know quite a few of his classmates. And since I would be there at the college, sometimes I would go in and watch performances. And the thing that you notice about music that's very different from other industries, I guess, is like they are brutally, the teachers, the professors in that space, even the students, right? Like they are brutally honest with each other about how bad they are or how good they are. And it's just power law, right? You're always going to have in any particular subsection, right, of that endeavor, you're going to have those one or two people who literally practice every hour they're awake. And they don't do it like 3 days a week. They don't do it 5 days a week. They do it every day of the week. And and so there's this focus, and there's this just maniacal dedication to honing their skill. And it shows, right? But what you also notice, it's not just one person, right? There's a couple, or maybe perhaps, up to 5 in different instruments, or some classic, some jazz, whatever. But it's not like they're singular. But even then, only one guy that I know of that graduated with my brother hit it big. And the instrument that he plays is not flashy. Like, it's not what you would think of as a rock star, or that's cool. But he's the only one. And there were a lot of talented people in that group. So I guess the point of that story, in my mind, is talent alone, dedication alone. You have to have those, right? But it's not sufficient, unfortunately, because so I guess in some sense, I don't know where this came from besides the movie Field of Dreams. But as a culture, we tend to have this belief. I really don't know where it came from. Build it and they will come. right? Like if you just produce the thing, that's it, right? Like that's the most important part. And yes, you have to have the thing. And I guess maybe that's where the notion maybe came from, was that people weren't even, getting to the thing, whatever that is, composing the hit, performing the hit, making the game, making the accounting software, whatever it is. So I don't know, maybe it just became easier to focus on, well, you can't even complain until you have, at least until you've tried to build something, right? But that misses so much of what's truly required. And unfortunately, and you will see this, like, look, making software is not, building complex software is not easy, right? And I couldn't do what I'm doing right now without all the years of experience I've had. I wouldn't even know where to start. So but if I'm very objective about it, the biggest obstacle to me building things is just me, right? It's just life. Do you let yourself get distracted such that you aren't focused on what you're doing, right? But even then, once you have it, once you've produced it, you, to some extent, like the follow-on steps to making it big are out of your control. And I mean, unfortunately, it kind of comes down to who you know, what connections you have for everything that comes after building the thing, right? Like, yeah, so a lot of luck is, I think, ultimately what it comes down to. I mean, that doesn't mean that you don't have to work, that you don't have to try, you don't have to hone your skills. You do, but like, those things are just, those are the door fee, right? That's the cover charge, right? You being talented and you being able to ply your craft efficiently, consistently, and get to the finish line of having something like, that's the cover fee, cover charge. Now you're in the door. Now you have to go ask the hottest girl or guy or whatever in that bar out on a date, and you are a nerd. And just imagine how difficult that is. And what is the likelihood that you will score that date? Pretty goddamn low, right? So that I think, it's not a perfect analogy, but like as I visualize that analogy in my mind's eye, that's pretty close. And my mom always used to say years ago that life is like high school. And she was right. I mean, I never actually went, but I had friends that did, and I could observe things from a distance. And, I mean, if you happen to if you went, that there's a pecking order and that people get sorted very quickly, and there is a popular group. There is I don't know the right word for it. There is an alpha group, or there's an ascendancy of certain people, right? Like you can see where they are on a trajectory to be famous, to not, and I mean, I hate to say this, but those people are not always the smartest. They're not always the most gifted. They may not have any talent at all, but for reasons that are very human and very messy, they end up getting the attention. God, this is going to get me off on a tangent, but oh well. Now my brain's there, so I got to go there. This, this was like a year or two ago. Year and a half. Yeah, year and a half. So my son and I went out on a walk, and where we were living at the time, the city of Washington, Utah, had just built 2 new schools just down the road from where our house was. And we walked out there, we walked around, the campuses. They're huge. One was a middle school, one was a high school. And I made the observation to my son. I said, look at the percentage of real estate that is dedicated to sports. I mean, it's massive. They have a full baseball field. They have a football field. They have tennis. They have, athletics takes up an extreme percentage of the real estate footprint of these schools. And when you walk by the baseball field, when you walk by the football field, there are sponsorships from all these local businesses. They have a full concession stand. They have, it is, if you didn't know better, you would say, man, this is a business, right? But I made the additional observation I said, why is it that a football player gets all of this? Even the worst football player on the team. But you don't even have to talk about the star, the quarterback, whatever, whoever that might be. Excuse me for a second. I think my sneezing fit is about to start here. Sorry. Pollen count high. But yeah, not even the superstar, just the lowest guy on the totem pole on the football field, by imputation, gets all of this prestige, gets all of this attention, right? And again, none of this discounts. Maybe they're phenomenal athletes. I don't know. But at the same time, the messages are very confused. And by the way, I am speaking about the United States. It's probably very different in other countries. This is just what I know. But the observation I made to my son was, where's the chess? Because the high school has a chess club. Where's the equivalent for people who are academically gifted? Where's the equivalent for? There is none, right? And so on the one hand, but we're talking about high school here, right? We're talking about kids. We're not talking, even, okay, college maybe, but even college is crazy for the same reason, right? I guess the short point of my story is that what people say is important and what people do are two totally different things. And if you look at what they do, that is the more accurate indicator of reality. And to that point, I guess what I'm kind of saying is, if you were to talk to a high school guidance counselor, they would be all about getting the highest scores on your SATs or whatever. They'd be all about getting into some kind of STEM discipline and getting a degree. And it's not that they're lying to you intentionally, but all the machinery around them is not behaving that way. The football players are more important. If they took every dollar they spent on all that ostentatious real estate for the football team, disbanded the football team, or, hey, if you guys want to get together and have a community football team, go for it. But we're not going to pay for it. And put every one of those dollars into people learning, but they don't do that. My high school spent millions on sports. Science teams didn't get funding for snacks. Yep, exactly. Exactly. Well, and that's part of the other issue is that in the United States, most public schools are funded through property taxes, and property taxes in a lot of places are already insanely high. Utah is kind of a weird case because of arrangements with the federal government over land. Utah funds most of their school system in a different way, but even still, people complain about how expensive it is, how underpaid teachers are, how they can't attract anybody to become a teacher, and yet they will put, that stuff that they built, it's massive, guys. There's broadcast, there's a broadcast booth, there's TV equipment. It's insane. It's easily probably close to $10 million, if not more, probably more. But yeah, anyway. Yeah. Oh yeah, I'm sure money is disappearing. No doubt. No doubt. Yeah, well. Okay, so for reading a file, it's only a tad bit different. Interesting. So he's actually restoring it after every evaluation, which I guess kind of makes sense because it's a limited size. Okay. Okay. So to evaluate a file, we're going to open it. If we don't get a file handle, it's bad, okay? We're going to store our GC index on the stack. We defer a final restore on that. And we defer closing the file. We loop. We read the next expression from the file. If that's null, then we didn't read anything of importance or we're at the end. So we're done. We assign the output object to the result of the evaluation of that expression. So that means that we're going to get the last expression from the file. I don't know if that's exactly what I want, but for now, that's okay. And then in the API documentation for the scheme interpreter, the author shows that he's restoring the GC stack after every evaluation pair. I think ultimately that kind of just depends on how aggressive you want to be and how small your heap is. So I think the size of the stack is fixed. Yeah. So it's 256 entries. So yeah, I mean, that probably makes sense. So this is going to keep reading valid S expressions from a given file until it can't find anymore. And then we're done. Okay, so now, like, that's the bare bones interface for this thing. Being able to initialize the module, shut down the module, evaluate a string in memory, evaluate a file. Now we have to decide how we want the configuration part to work. And so there's two ways I can see this working. One is configuration data lives in the scheme heap because, hey, we've already allocated 64K, a whole whopping page of memory on Windows. we might as well use it, right? But you got to keep in mind that like everything would have to fit in there. And then, what form, how exactly would we want to represent it? So there's, the obvious way is just, the scheme interpreter has an environment map, which is an association list. Not the most efficient data structure on the planet. But, you could just set variables, assign variables in the environment. And then, I could implement a public API that would let you look up variables by name from the heap. And I'm sure there's actually already an API in there that more or less does that. In fact, I think he has an example here, of how to call an existing function. So I'm guessing the FE symbol function will find something that already exists or create it. Well, actually, in this case, probably would be an error, but so let's look at the FE symbol. So it's exactly what I assumed, right? He's gonna walk the linked list looking for whatever name you pass in, and if he finds it, boom, there you go. If not, he's going to create it, and it's just an empty pair at that point. So, that could work. The downside is I don't like that because, like I said, linked lists are not the most efficient data structure on the planet. And I really don't want to look stuff up by strings, even if at some point things maybe are referred to with a string name. I want to try to translate those into integers so that we're not constantly having to look up strings. So that's kind of a negative of just having things living in the scheme interpreter heap. So the other option is what I would call the kernel approach, where for each unique thing that we can configure, we create C functions, C++, but they're just plain old functions, and we register those functions in the scheme interpreter, right? So we're going to put some symbols in our init here, right? We're going to register some functions, but the things we're putting in that linked list are pretty small number of them. And they're all functions. And then those functions represent different aspects of configuration that can be manipulated. But because those are native functions in our struct here, either in this struct, or we would actually just talk to specific subsystems directly. And we would affect the configuration directly against those those systems. So, one example would be the logging, right? So, like I said earlier, the default allocator and the default logger, those are always going to be there. They're kind of, and the context, right? Like this is just kind of the floor that we have to get built to do everything else against. So then we initialize the config system, and you could imagine that we could have a call to eval here that loads a known config file. And then perhaps we expose some kernel functions that are actually C functions that get called and allow you to create loggers. So there'd be a series of calls that you could make that would create a color logger or a syslog logger or whatever, all the different options that are there. Well, then this code can come out on the C++ side. It's now part of the config. And so that's kind of the power of the kernel approach. Likewise, with the kernel approach, like string localization, we can create a strings module. I don't think I have one. No. Yes, we could create a strings module and have a series of kernel functions that allow us to register or remove or whatever localized strings. So what that gets us, I think, is these kernel functions can optimize for each particular subsystem they're affecting. So we're not boxed into, everything is a symbol in the scheme heap, and we have to troll this ever-growing snake of a linked list to find stuff. It means that this config module is very simple and tight. The scheme interpreter is going to have very little in it that is overhead, right? Obviously, the kernel functions we create, that's it. And then when it's processing scripts, there isn't going to be any detritus hanging around in the scheme heap. So we could probably aggressively, compress how much memory the scheme heap needs down to where it's just tuned for it to run. And then that's good enough. Hey, Albie. So, I think that's the right idea. So, what would that look like? So let's look at the logging example, because that's kind of probably the best articulated. So let's see. I know he uses the equal. Right. Okay. So we could have something like make SPD color logger, and then color type. And what else do we have? Okay, so we would need name. I think there's probably other options in there I'll have to look at. Then we have make syslog logger. And we don't really need to cover the default because it's already created. But we could also expose, you know, the actual logging calls themselves. And so on. So that we could actually generate log output in the config file. And yeah, I'm writing these in Scheme, but these functions would be in C++. I'm just doing this as more kind of like roughly what they would look like, or what the API would look like from the perspective of Scheme. So that's one system. Then another would be the localization. So I mean, I'm just thinking it'd be something like string ID locale, and then the value. And then there'd just be how many ever strings we have. And then obviously if a particular string is localized, you'd have two entries for it with different locales. And then the string function on the C++ side, which would be in our config module, would use the string module, you know, hey, is there already an entry for this? If there is, it's an error because you put it in there twice. If not, go ahead, create the entry, all that good stuff. And likewise, like, so, okay, these, if I rewrite these as calling from a caller's perspective, of course, the syntax highlighting doesn't work right. Of course. So then, what other options are in here? That's it. Pattern and type. Right. So then, this thing doesn't have optional parameters. But we could pass something like a pair. So if this is nil, if we pass nil here, then there's no pattern. Something like that. And then for the options, it could be a list. Right, and on the C++ side, we know they're ORed together. So this is kind of what I think the config file would end up looking like. And we could put some we could put some symbols in the dictionary on the C++ side, like what platform are you on, so we could have conditional configuration. So we could say, if Windows, then this or that. So we could have Windows, Linux. Of course, that gets kind of nasty. So we could just say platform, and that could be Windows, Linux, macOS, whatever. What, he's using equal for assignments. I'm not sure if he's using double equal for equal. Maybe he doesn't have it. Let's look at that. He has less than, equal to. Interesting. No greater than. That's interesting. So it's let, set, if, function, macro, upload. Okay, so is equal. And then obviously he just makes all of his conditions such that they could be expressed as less or less than equal. So then it would be is, platform, Windows, right? Okay, fair enough. And there's probably some other, variables, constant variables that we could create like that would be applicable for conditional configuration. And then the other thing so strings are just that. It's just a string. Errors would be something like the ID, the code, like, I don't know. And then 32, 36, right? So these would be the string IDs for the message and the details of the error. And if there were no details, just pass nil. So that's what that would look like. And then at the beginning of the stream, I mentioned that I'd have to go back and for the status structs, right? These would all be 0, and then this would be some string ID or error ID. And I'm doing it that way because it's easier. And it avoids getting into bootstrapping issues between so because some code bases, what they'll do is they'll have localized, right, and they'll put something here, and then they'll have a tool that they write that goes through and strips all that out. But you have to build that tool then before you build everything else. And then if the tool wants to use the libraries that you're building, you see what I'm saying? It just ends up being kind of a nightmare. So this is, I think, pretty manageable. And like if you get the wrong message, if you get the wrong string or the wrong error, whatever, okay, the code says 22. What's 22? Oh, it's not there. Okay. Or, oh yeah, that's the wrong thing. It's not that hard to work with. So, and as long as okay is always 0, the existing code around that macro will work. So, that should be good. So, yeah, this is what's next. So I am going to take a short break, and then I will be back, and we will do this. And my day in the life of a non-millionaire programmer as a non-millionaire will continue. So stay tuned. I will be back. I'll be back. As a non-millionaire, during my break, I eat a protein bar. I got coffee. I used the facilities. I spoke with my wife for 2 minutes. That's it. Very unexciting. And yes, I do have a stack of Monopoly money that I play with. Pretend it's my real millionaire millions. I need to send one text message. Okay. Okay. Let's just do something simple to start with. Hey, Cyanox. Oh. This? I'm honestly trying to remember. I wrote this code a while ago. There was something. So, some background on this code. The profiler module is using the CPU instructions for so RTD SCP or something along those lines. So again, I'm trying to remember specifically, but I was getting a lot of variance on these timer calls, and of course, these timer calls are also, yeah, but there's also, I think, some side effects on the CPU itself that impact timing. Oh, no, it's not that they produce instructions. It's when this intrinsic gets compiled down to the machine instruction, the result of this instruction is sensitive to something, which I can't remember anymore. I'm going to have to go hunt through my notes. But there was something that was definitely causing a problem. This is bad. Like, I should have put a comment here, but I didn't. Well, as you just saw, like that profiling code, I wrote that I think like a year and a half ago. And it works. I mean, I tested it. I spent quite a bit of time on it to get it to where it was accurate. But I should have put some comments on some of that code, because now I only vaguely remember why I did what I did. But in general, and I try to write code. The profiler is kind of that is a sort of in the weeds case. But for most of this code, it's pretty straightforward what's going on. And for me, I code in a very specific style. and I try to stick to that very consistently. So when I'm looking at my own stuff, I kind of, because I know I follow a particular style and that everything conforms to that, things sort of slot into place, even if I lose some context. Reading other people's code, initially takes more time. But eventually I build a mental map of what's going on. And, my secret, I guess if it's a secret, is usually like with a new code base, what I'll do is get it to build, pick hopefully something that's easy to run. Sometimes that's not always the case, but I try to pick one code path. It doesn't really matter what it is. And I try to step through to that code path. And, depending on how complicated it is, that can take some time. But I find seeing the execution path of a particular project kind of helps me build that mental map of what's going on. And the title of the stream is totally ironic and not serious. I mean, it's a joke. I'm poking fun at Tech Lead. He's a YouTuber. Yeah. Uh-oh. Oh, sorry. I didn't even see the link.
Low anxiety, you've come to keep me company. Tonight a lonely soul. I've tried to learn the art of letting go. I'm craving something real, a kind of rush that I can feel. The night is rough, you know. I've cried, but I won't dare to let it show. What if the world won't bend my way? What will it take to be happy? Heaven knows you're lost, but you'll be fine.
He may be referring to my stream yesterday. Trying to remember, I made a change a while back. To one of the CMake files. And can't remember. What was I doing? Help me. Boom. Excellent. Babality. Johnny Cage wins. Scorpion wins. Fatality. Flawless victory. Okay. Okay, so I just created one function just for something simple, just to kind of prove to myself it's going to work. Not that I'm that doubtful, but I am an idiot savant, non-millionaire programmer. So in our init, I put the log info function into the scheme environment, point it at our static function here, and then this static function right now is just expecting one argument, which is a string. We copy it out and we log it, and we return false, nil. And then I created, or I should say renamed, that config file to core FE. have that one call in there. And so now, and I guess this is going to give us a chance to test our eval for this. I'll do it that way. This is bad, okay? It's bad. Oh, it's bad. Okay, that's better. I like that a lot more. Okay. Let's give it a whirl. Nothing ever works the first time. I know what I want to do. Yep, see, nothing ever works the first time. Especially when you're mentally challenged. Okay, so let's do it. Do it! Okay. Maybe better. Maybe. We will see. Up, up, up. There we go. But beautiful. That's so beautiful. I like it. Uh-oh. It failed. um... think make absolute will deal with that, but I'll just double check. Yeah, much better. Okay, wonderful. Now the question is why to blow up. All right. Alright. Oh, that time it worked. Huh. Uh-oh. Uh-oh. So we should... Oh no, there it is. Yeah, I should make that stand out more. Stupid thing. This is one of the rather annoying aspects of CMake. Post build is very literal. If it doesn't change, if it doesn't build, it doesn't do anything. Okay, good. So this is definitely coming from the config script. I'm guessing that we're blowing up in here somewhere. Trulian, I'm working on some library functionality, which is part of a larger project for a compiler. Alright, let's do this. I'm trying to narrow down where the problem is. CMake. Oh. That's kind of weird. Let's run that again. Just to be safe. Okay, so it was still failing, even not calling the evaluator. I'm guessing this is coming from, it's coming from the memory allocator. Something's leaking. 318 bytes to be exact. So no, that's fine. Well, it's got to be the path stuff. Um, remove some moving parts. No. Well, now it's only 190 bytes. What's the length for this? 60? Oh, damn it. I know what's going on. Yeah, this is one of those one spot where I can't use defer. Yep. Okay, good. So that works. Now, that was the simple. But making it more complex. So I'm guessing next arg. Maybe not. Yeah, so I'm just thinking about like so unfortunately the C++ format library, which is actually a part of the standard in C++ 20, but I'm using the unbundled version, just because that's what I started with and it works fine. But it is truly a compile time beast. And it has some features for dynamic parameters, but I don't know, the last few times I've tried to use them, it was really a pain in the ass. I'm just looking at the documentation. The other issue is the way that FE next arg is written. What I would want is for this just to return nil. Because then I could just keep calling next arg until I hit the end. So I could create my own version of this. It's not a complicated function. because I know one argument is I should have at least one argument, which is the format string. And then what I could do is just have a loop here, keep getting the next argument until it's nil. I'd have an array of those, and then I could do something with it. Let's see, documentation. Here we go. Okay, so yuck. I mean, that's one way. Oh, yeah. That's not really going to work either. All right, that might work. Nope, no. Yeah. And that can be... Okay, let's try that. Okay, so that's my version. So for the first argument, we'll use the library because we require the first argument. Now I'm going to have to hook the error stuff. I'll do that last, but we do want this to trigger an error if we don't in fact have that argument. But everything after this is optional. So just oops. So if I spell it right. This isn't quite right though. to start with, we're just going to worry about numbers, symbols, and strings. And I guess mill we can output as a string. Make it a little bit shorter. Oh, this shows context. There we go. Okay. And then for numbers, strings we already kind of know what to do here. And symbols. How do I get? Hey, yes, Wills. Yeah, that's probably the easiest way. So these are really kind of the same. You just use 2 string on it. And actually, we can do mill the same. Oh. Really? Shit. I mean, can you... Yeah, let's just do that. Sometimes I'm slow. I remember. Yeah, it doesn't like my type. Urge to kill rising. Still doesn't like it. Oh, I remember. Oh, see, this is that. got grandpa brain, you know. But eventually, I remember. Ha. Gotcha. Okay. Oy vey. Okay, so let's go to our test script here and $47 because it is the answer. And then let's just do a symbol for the hell of it. And I guess, you know what, while we're at it, let's do a string and no. So, hello world and no. Of course, why is CMake doing that? Oh, do I have something fucked up in my copy? So what does buff look like? 47. Foo. Hello world. Nil. Ah. Yeah, that's a problem. Because nil is our sentinel. Yeah, so, okay. We can't do that. We can't format that. That's all right. If fe type context FET, no. Okay, so that's our sentinel. Okay, let's take a look at that. That would be why. I'm a moron. Yeah, I win. Gold star. So let's look at our array. Yep, so it's one of their little doomedads. Oh, I'm so stupid. Stupid. Sorry. Hey, and now we have a reason to use the return value. Oh, seriously? Fine. They seriously only do it that way? I got some splaining to do to myself. This, it helps. Man, it's been a while since I've looked at this code, but I think when I converted its concepts, yeah, it's right there. Oh, gosh darn it. Yeah. Okay, there we go. Yay. Look at that. Okay, so so the format string we got to cache because we keep reusing the same buffer, which was not my original intention, but that's okay. And that's the way the cookie crumbles. Okay. You can find the fonts here. I am specifically using a font named Pro Font, which is an old Mac font that I like. Oh no, what did I do? I was absent from streaming for 5-ish months, so yes. Should you declare an operator overload as private? I wouldn't. If you're going to go to the effort of overloading an operator, then that has to mean something. For the type. So, I mean, unless this particular type is only ever used in a private context. So, yeah, I would make operator. I would generally say that operator overload should be public, but that's just me. I was thinking of code. I was thinking the way this code was like a long time ago. I'm like, oh my god. Yes, the stream title is, yeah, definitely a continuation from yesterday. Yeah, damn. I should have done that. A non-fang, non-millionaire programmer. Yes, that's a much better title. I will call it that on Facebook. Noon refer up. There's a link to where you can get the fonts. The font is itself. It's called ProFont. Okay. What is it complaining about? What did I do? What I need to do is I need to get a bot that is better than the one I've been using that recognizes, patterns in text and has canned responses for that stuff instead of commands. Because then people don't ever know the commands, and so then I have to tell people the commands, so it ends up being the same thing. So I actually need a bot that can just answer about 500 questions that are very common. And why the answer to why is because. Okay. Oh no, what did I do? Okay, so format string, yes, should be our format string. Yes, I thought it was good. Ah, yeah. I think I know what's wrong. Mm-hmm. Argument index out of range. No. Oh, right, but it probably didn't copy it. Nope. Yay! There we go. This is a test. Hello. Oh, no. That's not right. Oh, but it's runtime. So, yeah. Watch, this time it'll copy. No? It's always Hello World. What is wrong? Length is 37, which looks reasonable. Length is 37. Three arguments. C string type, so it's recognizing what it is. Hello. Ooh. Interesting. Oops. Oh, I'm so God, I'm so stupid. Somebody's shooting. I'm so retarded. Yeah, it helps if I don't do the same thing multiple times. Look at that. Well, then again, oh, gosh darn it. Of course. What's a better way to do this? Okay. So I have this nifty container called string array, which has one contiguous buffer. So as you add strings, it will resize the buffer, and then internally it has an indexing structure that lets you get to a slice of each string. Now the pointers in this are not stable unless, of course, you resize the buffer up front. And since we don't know, without looping multiple times over the arguments, we don't know how many strings there are or how big they are. So with that in mind, what I did is, because the problem with creating the strings in the loop is that string T is the only type I have that has a destructor on it, which it's on my to-do list to decide if I want to keep that or not. Strings are kind of messy, and there are pros and cons of having a destructor on it. Not up until this point, I've decided I should leave it, but of course, what happens is exactly what happened here. That string was just being destroyed. So the string array is the answer to that problem, where you have to have something that has longer term scope, and you want to collect a bunch of strings together in contiguous memory. So we do what we were doing before. We append these strings to this string array, and then we loop over the string array afterward and populate the argument array, which means, just from a happy, joy code cleanliness perspective, that I can move this just so it kind of reads in line as it's being used. Okay. It's so funny. Uh-oh. I broke it. Huh? Oh. Yeah. No. What are you complaining about? Boy. Haha. Sorta. 47 food. Hello world. We'll get some over in here. I thought I took care of it. Yeah, it now terminates. Oh shit. I know what I did wrong. Oy vey. Helps if you allocate some room for the knob. There you go. Wow. Okay. After all that. Whew. All right, so we're going to want a log for all the different log levels, and we're not going to want to do this for everything. So let's break this out. Oops, I keep misspelling that. Now, so what we could do to be even more clever, yeah, so we have a shared buffer, which I pre-size to 256 bytes. And of course, it'll grow if it needs to, but we can fine-tune the pre-allocation later. I put a mutex on there because if multiple threads try to do this, it's going to be bad. Of course, multiple threads should not be calling the logging system, but for now, I'm going to put the safeguard on there. Or I should say, multiple threads should not be initializing the configuration system. Put it that way. But I can always come back and optimize that out. So I'm not too worried about that. So now the code that deals with taking the scheme objects and getting them converted so that the format library can be happy with them. That's all in one function now. And then for our variations, if I could type, so we have info, we have debug, and then we have error. What else do I have? spots. You're welcome. Have a good one, Synox. All right, so we have info, debug, emergency, alert, critical error. Let's do this smarter. Yeah, smarter. Not harder. There we go. Yeah, now we have a nice mechanism for registering our kernel functions. Good. Okay. So there is a bug here. We need to reset the shared string buffer. Subsequent loggings would have just kept growing. When I hot deploy a DLL on Windows with concurrent unordered map, it works. But when I hot deploy an SO on Linux with TBB, which is the source MS used for its implementation. The SO reloads but fails silently. Is that because the TBB is a static lib and you cannot hot deploy a dynamic lib that depends on a static lib? Well, no. I don't think it would be because of static lib, because if it were static, it would have just been linked in to the shared object when you recompiled it. But there are some things to keep in mind. DLLs on Windows are very different from shared objects. So first off, DLLs have lifecycle callbacks. Like technically in Windows, DLLs can have a main, and they have pseudo process status in Windows. So dynamically reloading DLLs in Windows is operationally and semantically a bit different than Linux. So it depends, right? If there's behavior in a DLL that is lifecycle related, in other words, in the Windows version, there's like setup and tear down behavior. Then that may or may not have a direct correlation on non-Windows platforms. But yeah, like statically linking a library. So you could statically link a library into an executable, at which point you would just have to redeploy the executable. You could statically link a library into a shared object or a DLL, and if that's the only DLL or shared object that has that code in it, and everything else accesses that behavior from that one shared object or DLL, in theory, it should be okay. But the other issue you have to be careful of, and I haven't read this Stack Overflow, but when you statically link things, you are giving the linker the opportunity to strip unused symbols. And if you're not careful, certain libraries don't like that, right? Like you can't exclude certain things even if they're unused. You don't run into that with shared libraries and DLLs because by definition, those don't get stripped, right? Because you're only dynamically accessing the parts that you need. Well, so then if you're linking statically, then, and the library has to have unstripped symbols, that starts to get really complicated. So here, I'm reading the Stack Overflow that you linked. Correct. Okay. Yeah. So this is what I assumed. TBB, which is what I thought it was, it's the Intel threading stuff. It's replacing and extending threading and task behavior. And this is one of those special cases where the whole library has to exist in a shared image that isn't susceptible to things being stripped out. Additionally, just from reading this, it reads like there is definitely life cycle related functionality in this shared library, because they're controlling threading for you. So there's probably a lot of Arcania in here that's dealing with process startup and, making sure that they're taking over thread local storage and all this other stuff. So yeah, it looks like while you might be able to find a way to statically link it, it doesn't look like it's, I would just, based on this, I would say it's not worth your time. I mean, just link it dynamically and you're good to go. Yeah, the music is good. Unfortunately, YouTube does not do any kind of EQ volume leveling across videos. So some of them are very quiet and some of them are very loud. Okay, so let's review what I got here. I'm going to have to wrap up for the day. All right, so in the core library CMake file, I am copying the core config script, which right now just does a simple logging call just to kind of verify that it works, which it does after some, great episodes of me being a moron. I need to revisit this. Post build is not the right thing to do here. I need to you can create a custom target that's based on a target file, and then it'll copy it if it's newer. So I need to do that. But for now, this mostly works. But I'll fix that either later today or tomorrow. When you create custom commands in CMake, they're very long-winded, right? You end up saying command, CMake command, -e. So a while back, I created some variables that just sort of shorten those up. Of course, earlier I had to scratch my head when it wasn't working right, and I forgot to delete parts. And anyway, so I added CP because I didn't have just a plain copy. In the config module, there's some new stuff that's growing, right? So first, I have in the system struct, which again is private inside of the config module, and there's only one instance of it in the system. We have code now that is, whether it's a string or not, it's not really relevant. String T it's a byte buffer. So I have a string T in here, which is just reused in a bunch of places. And I'm probably going to extend this a little bit because we have a couple other buffers that we can probably just consolidate into one shared buffer with some helper functions. And I put a mutex in here because just in case multiple threads did in fact execute a script, which actually won't work because the scheme interpreter won't support that. But at least the config module, in theory, is thread safe. I mean, I'm probably going to eventually back that out, but I'm just putting that in there sort of as a guard for now. And I'll optimize things away. As I was implementing my first kernel functions for doing just logging, it became clear very quickly that the built-in fe_next arg function really wasn't quite working the way I wanted it to. That version errors out if you try to go to the next arg and it's not there. That's fine if your purpose is to only have code in functions that use required parameters. But if you have variadic parameters, which in this case the logging code does, I needed a version of this that just would return false or nil, whatever you want to call it, when we hit that case. So this is just a local version of that function instead of changing the core library. And then vlog is a helper function that all the other log kernel functions use because this code is ugly and only deserves to be in one place. And essentially what this code is doing is we're passing in the scheme context and the scheme argument list, right? So this is a scheme conf object that has a car and a getter and goes through a list. So the very first argument, right? And you'll see here, I'm using the library version of nextarg because in this case it's required. So if it's not there, we would want an error to be generated. Now I'm not validating that it is a string. I could do that, and I probably will slowly refactor this code to be more strict. But for now, I'm just calling toString on that object and putting it into our static buffer here. I would like to hoist the static buffer out and either just consolidate it into the one allocated buffer we have, or maybe we have two of them. I don't know. But we can do 4,096 bytes of stuff as that first string. We have, I need to copy what's in this temp buffer though, because we reuse the temp buffer multiple times. So I create a string here, put that 0 null terminated string in there, and then we're going to go through this variadic list of arguments, which may be empty, right? There may not be any, and if there isn't, that's okay. But if there are some, we need to go through each one of those scheme objects. So if we look at the example, right? So this is the first argument. We expect this argument, and it should be a string. And then the formatting codes conform to the format lib for C++, which is actually part of the C++ 20 standard. And then these three arguments are what get filled into this these format placeholders. These are optional, right? So this is optional. So this while loop is going to walk over that linked list and turn each one of those into a string. And we append those strings to a string array. And string array is one of my own containers that's kind of optimized for accumulating strings in contiguous memory. They're null terminated, but I also store their lengths, and so it kind of works in a bunch of different use case scenarios. So when this loop is complete, we may or may not have strings in this. So then we create an array which holds this format arg type, and this format arg type comes from the format library, and it's one of his crazy template things. That part, the way you think of that is, as long as I have a contiguous array of these structs, then I'm good, right? So we initialize that array. We have a defer to free it when the function returns. And then we loop over how many ever strings we accumulated when we were converting those variadic parameters from the function call. And then we append an argument type from the format library, which encapsulates this string. Now, this is kind of silly in a way, because the format library is intelligent, right? Like, so it doesn't just know strings. It knows numbers and pointers and custom types too. But in this case, converting these to strings I think it's okay. I could probably eventually revisit this if I really wanted to make it, type sensitive. But the problem is this is all at runtime. So at that point, if it blows up, it's going to blow up with a really nasty error, and it's not very helpful. So anyway, that's why we're doing all strings, even though technically the format library is smarter than that. This shared, so we pass in a reference to the shared buffer that we want to write to. I made this function naive of the global environment on purpose, because it just makes it a little bit easier to refactor. So we reset that buffer, right? And then this stir buff t is a wrapper I created that allows me to pass in a pointer to one of my string types, and the string buff t is type compatible with the buffer type that the format library expects. And then we directly call into the format library, and this is variadic format 2, right? So 2 is the buffer we pass in, which has, again, to conform to this buffer interface that the format library specifies. We pass in a pointer to our null terminated format string, which we got up here. And then we convert our array of format arg structs into a format args, which is the plural, right, of that. And then voila, the format library does its magic at runtime. And just a quick note on this, dealing with variadic anything sucks in general. So, doing this with like VS printf or something like that maybe have been a tiny bit less code, but not much. So, and the nice thing here is that this is consistent with the rest of the system, right? Strings are being formatted the same everywhere. So then these are our kernel functions, right? And the kernel functions follow very specific prototype. They return an object pointer. They take a context. They take an object pointer. Again, because it is not thread safe to call these. These are not thread safe. I have a scope lock on our mutex, so this ensures that only one thread at a time will call this. Again, there are other reasons why that shouldn't be happening anyway, but for now, I put that in there just to kind of almost as a reminder, right, for myself. Like, I'm going to look at that over and over again and say, wait a minute, that should never happen. But it isn't really costing us anything. It works. So then we call the shared vlog function, and sorry, I'm going to have to run the music through a local EQ. I think I could do that. I'll have to figure that out. So I don't have to chase after the volume all the time. So we call our shared vlog helper function. We pass in the context, the arg, and the shared buff that we're going to use. And then we call the logging system. Now, the logging module in this library, the way it works is it's designed around simplicity of use. You may have to do a little bit of work to set it up, but once it's set up, the idea is user code just calls these log functions. And loggers are chained. So you can specify there are overloads for each of these that takes a specific logger pointer if you want to do that. And there might be cases where that makes sense. Here, by just calling these APIs that don't take a logger, the logging system walks through the logger chain. So all the loggers that are created, it chains them up, and you can create parent-child relationships explicitly with loggers. So that's all handled automatically for you. That's why when I run the tests, you get a bunch of the same messages multiple times, because they get filtered out to all the different loggers automatically. So for each log level, we have one of these kernel functions. Now, this is always one of those interesting API debates, right? Like, well, why have all these, like, this is even this is a bunch of repetitive code. Why not just have one of these, and one of the arguments you pass in is the log level? We could do that. I was thinking about that as I was writing it, right? So in theory, we could have something like this, and whatever, we'd have a symbol that matches the log levels. We'd have to convert that, and actually the right way to do that would be, we would pre-create those symbols at initialization time so they already exist, and when they're created, we would keep track of their index or something in the heap so that we can use an integer as the ID. And so then we only have to compare index values or something like that. So that's definitely a possibility. So yeah, I mean, that could go either way, in my opinion. I did it this way because it matches what the logging module does right now. But I may revisit that. And then I created a struct that allows me to model a kernel function generically, right? So we need a symbol and we need a pointer to the function. And then I've got an array of those structs, and I use null as a sentinel. Ah, crap. Spaz. So I use null as a sentinel so we can just keep adding things to this list. And the init function will loop through this list and register these as symbols in the environment and these as the functions that they point to. In the finalizer for the config system, I free our shared string buffer, I free the lock, the mutex. In the init, we initialize the shared string. I pre-allocate 256 bytes. I'm actually kind of thinking that I would just change this to like pre-allocate 8K or something, and then we'll just reuse this for all the buffers and get rid of that static buffer. Even though like the static buffer is not a big deal, just might as well. We're already allocating some memory dynamically. We might as well just use it. And in the grand scheme of things, 8K is nothing. So we initialize our mutex. We initialize the scheme interpreter. We loop over our kernel function definitions. We register those into the interpreter environment. And then I also created a version of eval that takes a path and opens that and loops. So evaluating a string only does one expression. So if you had a string that had multiple top level Lisp scheme expressions, it would only evaluate the first one. Now in theory, you could like bump the pointer and call it again and call it again and call it again, and it would like successively evaluate the string. But this version is designed because we're assuming there's going to be multiple things in a script. This is designed to loop until the reader says, yeah, I'm done. And we evaluate those, and that's how our config stuff gets executed. I used a defer here to restore the GC just to be consistent, because if there's an early exit here, I wasn't calling it. So that's why I like defer. It just saves me from screwing myself in situations like that. Had to include the path header. I talked about the reason why for our status structs, I'm going to be explicitly assigning integer IDs to everything, because when we do string localization and errors, it's just easier if everything's explicit, and it avoids bootstrapping chicken egg type problems. And then we have the prototype for eval that takes a path, takes a pointer to a pointer of an object, which is your result. This is our test script. That's going to grow as we extend this. In the test runner, so this is the main of the test runner, we need to initialize, we need to now execute at least the core config file. So there's some path stuff here. And I've just, through experience, like Nixes, like Mac OS, BSD, Linux, they deal with relative pathing properly. For the most part, Windows has issues. So I've found it best to just normalize paths to absolute paths. And one of the things that the system does is when we create the context, we pass argc and argv in, and those are available then globally to everything. And what I really should do with this, because I've got this code now in a couple spots, and this is kind of nasty, and I actually mucked it up early on, is I should create a helper function in path that is specifically meant to create safe absolute paths from the context. So that's on the to-do list, so that this will end up becoming one line instead of it being like this. And then it'll always be correct. So, but once all that's done, we call eval, passing in that path. We get back the result object, whatever that would be. In this case, we really don't care, but I've got it in there. And then the main function is one function where I can't really use defer, because defer, the macro is built around RAII. And the problem is destructors happen after the function exits. And in this case, I already would have freed all of the subsystems. So I have to explicitly free these things down here. At some point, I may refactor that. For now, I kind of evolved this to this point because it was just easier to work with. I moved this. Oh, and the other thing too, so in string array, evidently I had never used this particular overload of append. I was always using the other one, which I think is in the header. And I wasn't allowing length to be passed in. So I changed that. And this came about specifically because of what I was doing in the log stuff, right? Where I was trying to append C strings, and I already knew what the length was, so I didn't want to pay for Sterling to go walk bytes again looking for a 0. So kind of wasteful, so I fixed that. And then the stir array header, this is where I fix this. It defaults to -1, and so if you don't pass this, it'll do the Sterling for you. Otherwise, it'll take whatever length you pass in. And then it's all good. So this is coming from our configuration module. And so that's good. Happy, happy, joy, joy. So let's test this real quick with Clang under MinGW on Windows. Because you never know. And then real quick, I'll test this under Ubuntu, and I'll run Valgrind on it just to make sure that it's all happy. Yeah, see, this is interesting. It didn't copy the file. Or no, it did. It's weird. Yeah, the ordering is a little bit different. And I don't know if that's Catch that's behaving slightly differently when it's compiled with Clang. It's gotta be. But yeah, it's a little weird. Okay, so it is working, but the order's a little bit out. So yeah, that's one of those oddities to file away in my brain. So on Windows, that looks good. Okay. So now we'll go to Ubuntu and pull that down. No, not that. CMake runs so much faster under Ubuntu. It's amazing. Yeah, good. There we go. I expected it to work, but I also have learned not to be surprised when it doesn't work. So I'll just run it standalone. That looks good. So let's run Valgreen on it. Ah, see, this is why I do it. I am leaking something. Okay, so I'm going to make a note of that. I have a guess at what it is, but I could be wrong. So, what does it say? It's tiny, whatever it is. Okay. I definitely did something because Valgreen was clean when I started the stream, so it's probably something really stupid. Hey, Chromium, it's okay. Making slow progress. Okay, so got to look into that. Good thing I tested it. All right, so yeah, I'm pretty happy because now, like, the trail is blazed. The plumbing is there, and the other kernel functions we have to create are, I mean, I could be wrong, but hopefully they will be fairly straightforward and not nearly as hairy as what we just had to do with logging. Like, I thought I was picking off something easy, and instead, like, picked off something that was a pain in the ass. But it's a good, you know, it's good exercise of all the functionalities. So that's good. So probably later today, I'll take a look at where that leak could be. Probably just need to audit the code closely, and I'm sure it'll jump out at me. It's tiny. It's 300 bytes. It seems to be consistent, which leads me to think it's probably one of these buffers I'm allocating. It's just not getting freed. And yeah, so then tomorrow, we'll continue on with this. And yeah, I mean, at this point, we'll get kernel functions for creating loggers. We'll take the log creation code that's in the main of the test program now out, and we'll create them through the config script. No, it's on GitHub, but I'm working on a local branch, and I plan on squashing this into the develop branch on GitHub. So probably tomorrow, my plan is wherever I end up tomorrow, I'll merge this into develop and push that up, and then I'll start fresh on my my local branch. Otherwise, it gets way too noisy. You know, I end up with all these retarded commits that, like, yeah. So, but yeah, probably tomorrow towards the end of the stream, I'll squash merge this and push it up to GitHub. Yeah. So anyway, we'll get the kernel functions for creating loggers. We'll get the string module and the error module sort of fleshed out so we can create kernel functions for those. We'll flesh out the config file for real and get rid of hard-coded strings inside of the code, move those into the config, and tidy up the code so that it uses the right API for all that. And yeah, so it'll be good. Any final questions before I head out for the day? All right. I hope everybody has a good morning, afternoon, evening, whatever time it is for you. And I will be back tomorrow for more fun and excitement as a non-ex-FANG, non-millionaire programmer. It'll be exciting. See you all then.